Hi, my name is Harshita and this is your Belmont Math Science Center tutor tip. Sometimes students get confused between all the functional groups we come across in organic chem. So in this video, I'll give a quick overview of all the important functional groups you'll need to know and try to give tips to memorize them. So first off, these are all the compounds that I'll be talking about. So you can see that I've divided them into three groups. The first group is hydrocarbons, which are basically compounds with hydrogens and carbons. So there's two types. There's aliphatic hydrocarbons and aromatic hydrocarbons, where aliphatic hydrocarbons are three types: alkanes, alkenes, and alkynes. And the second classification group is compounds with CZ single bonds, where Z can be a variety of different things, which we'll talk about once we get to these compounds. The third classification group is carbonyl containing compounds. So carbonyl basically means C double bonded to an O. So any compound that you see, like in organic chem, that has a C double bonded to an O is probably of one of these like this list of functional groups. So let's get started from the top, from alkanes. So alkanes are compounds with only C's and H's, again as I say, hydrocarbons, that are single bonded to each other. So that would mean they have only single bonds between each other and throughout the compound. And the molecular formula would be CnH2n plus 2, where n is some integer. I should say there are exceptions to this rule. This rule does not work when you're working with cyclical alkanes, but when you look at anything else, then it should work. Well, if you're looking at pure alkanes, then yes, it will work. So I have a couple of examples. Like as I said, this is a cyclical alkane, so it's a pentane, and here's a couple of just chain alkanes. So there's methane, ethane, and propane. And here's an example of a branched alkane. And you can count up the carbons and hydrogens in any of these four examples, and you can see that they follow this CnH2n plus 2 kind of like formula. So next up is alkenes. Alkenes are compounds with only C's and H's with at least one double bond. And their molecular formula would be of the form CnHn, where again n is some integer. With that being said, this formula only works when there is only one double bond in the compound. So all of the compounds that I have here have only one double bond. So this formula will work for all of these, but it wouldn't work for something that has two double bonds, or again, if it's cyclical. And the third aliphatic hydrocarbon is an alkyne, which is a compound with only C's and H's with at least one triple bond. So again, the molecular formula is CnH2n minus 2, and the same exceptions apply. This only works when there's only one triple bond and there are no cyclical compounds involved. So this formula would not work for this compound over here, but it would work for everything else. So those are the three aliphatic hydrocarbons: alkanes, alkenes, and alkynes. A good way to remember them, like differentiate between which one has the double bond, which one has a triple bond, would be kind of looking at the spelling itself. So let me go back up. So for alkane, you can see that they all start the same way, but then they differ by their suffix ane, ene, or ein. So the first one is ane, where the first letter is A, and compared to E and Y, A comes first, right? So that would mean it would have it would have single bonds, because like one is the same as single. And then you would go to alkene, and the first letter of difference is E. E, when compared to A and Y, among these three letters, E comes second in the alphabet. So that would mean it would have only double bonds. And then again down to Y, among these three letters, A, E, and Y would come third in the alphabet. So Y would have triple bonds. So that's how you can kind of differentiate between alkanes, alkenes, and alkynes, because I know they all kind of sound the exact same. So, and now when we move on to aromatic compounds, so this is something that I'm not going to go over too much, because one, this is something that we don't really look at much in organic 1. We just define it and then we leave it until organic 2, which is where you actually kind of go deep into it. And reason number 2 is it requires a little more time to explain, and there isn't that much time in this video for me to explain it because it's already so long. But you can obviously go to your professor and ask them more about it, or you can come by this YouTube page again later, and you might see that someone else might have put something else on, or there's multiple sources online that can help you with that, or again you can come to centers. But anyway, I'm just gonna give like a quick overview of it. So a compound is aromatic if it follows these 4 conditions. The first one is it's planar, which means it's flat, which is kind of a well-duh kind of condition, because you can't have rings that are not flat. So there's that. And then the second one is also another well-duh thing, because it says cyclical and rings are gonna be cyclical. The first ones are kind of pretty obvious. The third one means completely conjugated, which means every carbon in a ring is part of a pi bond. So you can see in these diagrams over here, this carbon is in this pi bond, this one's in this one, this one's also in this one, this one's in this one, this one's in this one, and this one's in this pi bond. And you can look at any of these compounds too. These are called polycyclic aromatic rings, or polycyclic compounds. And you can see that in any of these compounds, all of the carbons are part of some sort of double bond, which is representative of them being in a pi bond. And the fourth rule is that it passes Huckel's rule, which says that compound has 4n plus 2 pi electrons, where n can be any sort of integer. So, okay, now we're going to move on to the group with the CZ single bonds. So, again, the first type that we're going to talk about is alkyl halides. Alkyl halides are basically compounds that have an alkyl group attached to a halogen. And remember, a halogen is the column of compounds that you see right beside the noble gases, so fluorine, chlorine, bromine, iodine, and so on. So alkyl halides are represented in this way, so it's Rx, where the X can be, again, any of these halogens. And another thing that you would need to know for alkyl halides is knowing whether it's primary, secondary, or tertiary. And alkyl halide itself also has a 0 degree. So a 0 degree would be that the halogen is attached to a carbon, and that carbon is attached to 3 hydrogens. So if it's attached to 3 hydrogens, it's a 0 degree. But if the carbon is attached to one R group, where R group could be any type of alkyl group, then it's a primary alkyl halide. If it's attached to 2 R groups, then it's secondary. If it's attached to 3, then it's tertiary. So for these, you would look at the carbon that Z group is attached to. So remember that, because that's going to change in a while. So these are again some more examples of alkyl halides. So they can be like of any form. They don't even have to be like a chain. They could be branched or rings or all sorts of weird looking structures. So the easiest way to recognize them is to really just see if you see a halogen attached to a carbon anywhere. The next one is alcohols. Alcohols are an alkyl group attached to a hydroxyl group, which is also known as an alcohol group. So now that we learned about alcohols, from now on we will call that OH group alcohol, because that's what chemists do. Because hydroxyl is what kind of like what you call that OH group in Gen Chem, but now that you're in organic chem, you have to call it alcohol groups. So you've been promoted, kind of. So it's represented as ROH, and here's some examples over here and here. And again, alcohols also have that primary, secondary, tertiary classification, and it's the same kind of rules. So you look at the carbon that the alcohol group is attached to, and you see how many R groups that carbon is attached to. So if it's not attached to any, if it's attached to 1, it's a primary. If it's attached to 2, it's secondary. If it's attached to 3, it's tertiary. So the next one is ether. And ether is a compound with 2 alkyl groups that are joined by an oxygen in the middle, which you can see over here. So like there's alkyl, and then an O in the middle. So it's represented as R single bonded to an OR group. So that OR is the Z group that we talked about in the CZ classification. So ethers don't have the primary, secondary, and tertiary classification. But again, they can also look in any kind of form. So here's one that's attached to a benzene ring and an alkyl group. Here's one that's just like a chain, and here's a branched ether. So again, it can look like whatever it wants, as long as you see some sort of R group beside another sort of R group with an O in the middle, then it's an ether. So next is an amine, and amines are compounds with an alkyl group attached to a nitrogen atom. And this one is kind of more complex to represent because it looks different based on whether it's primary, secondary, or tertiary, which I'll talk about. So it can be represented as RNH2, R2NH, or R3N. So a primary amine, so this is the one that I said would be the exception in a minute. When you do the classification of primary, secondary, and tertiary, you would look at the number of carbons that are attached to the nitrogen itself. So you wouldn't go a step down and then do the classification. You would just go do it from the nitrogen. So in this one, the nitrogen is only attached to one R group, so it is a primary amine, and this is what you would represent as RNH2 because there's R, N, and 2 H's. And then you would go to the secondary amine where this nitrogen is attached to 2 R groups and a hydrogen. So that would be R2NH, and then the tertiary would be the nitrogen attached to 3 R groups. So that would be R3N. So I just had a couple of examples here, and they both just, never mind. This one's a tertiary amine, and this one's a secondary amine, because again, this one is attached to 3 R groups, while this one is attached to 2, and hydrogen. So the next one is thiol. A thiol is basically an alcohol, but instead of the O in the OH, like in the alcohol group, instead of using the O, you would use sulfur, S. So that's literally the only difference. So it's a compound with an alkyl group attached to a sulfur atom, and it's represented as RSH. So this one would, again, go back to the original classification that we talked about with alcohols and, what was the other one? One second, alcohols and alkyl halides there, sorry. So yeah, the primary thiol would look like the carbon that's attached to the thiol group would have one R group attached to it, and the secondary one would have two R groups, and the tertiary would have three R groups. Again, I know here there's methyl groups as the R groups, but again, remember that the R groups can be other stuff, but just methyl, like you can have a long chain or whatever. So, yeah, that's that. And then here's some examples of thiols. And the last one in this CZ group is a sulfide, which is, again, basically an ether, but instead of an O, again, we're using an S. So it's represented as RSR. And here's some examples over here, with it being in a chain, and, well, this one's a chain, and this one's a branch, and this one's in a ring. So if you would ask me, I would say maybe, here, let me rephrase this. I know we went over a lot of functional groups so far, and we still have more to go through, and I understand that this gets overwhelming. So I would, like, if you ask me, I would say you could kind of put learning thiol and sulfide as like a lower priority compared to like alcohol or alkyl halides, because we don't really talk much about thiols and sulfides. It's just a good thing to know, and I mean, as you progress on your chemistry journey, you will use these compounds more in the future. But as of right now, like in organic chem, there's more focus on the other compounds that I've talked so far, and that I'll talk about in a minute, than there is about thiols and sulfides. So if you kind of want to decrease the amount of things that you need to learn at the moment, not forever, at the moment, then you can just put thiols and sulfides aside. So now we're going to go into the carbonyl classifications. So again, carbonyl is acetyl 1,2-NO, and the first group that we're going to talk about is compounds with a carbonyl group that have an alkyl group on one side and a hydrogen atom on the other. So this picture over here actually shows the representation of aldehydes, and I put a picture up because you can't really type out that structure, or I don't know how to, so I just thought showing a picture would be easier. So, like, if you're talking about an aldehyde, or if you see this symbol anywhere, then that just means the author is talking about an aldehyde. So here's some examples, and a exception that you'll need to remember only for aldehydes is the R group can be a hydrogen. So for anything else, the R group has to be like a hydrocarbon chain, or a hydrocarbon chain with some other atoms in it. But for aldehydes, that R can be an H, so that you can have like a carbonyl group with two hydrogens attached to it, but that's the only exception. Everywhere else, the R group has to be something other than just a hydrogen. Okay, so again, here's another normal example where there's this CH3 as the R group, and then over here you see that there's a cycloalkane as the R group, and here, this is actually a symbol for benzene. I know it's not what you usually see, but that's one way of representing it. So you can see that here for this compound, the benzene is the R group. And here's another kind of longer example of an aldehyde where there's the carbon, or the carbonyl group, the hydrogen, and the R group has some alkenes in it too. So the R group doesn't have to be like just an alkane. So it can be like an alkene, an ether, or it could have other functional groups on it too. Like as long as it has this COH kind of part, then it's an aldehyde, or it shows properties of an aldehyde. The next one is very similar. It's a ketone, and a ketone is a compound with a carbonyl group attached to two alkyl groups. So instead of having an R group on one side, it's going to have an R group on both sides. Okay? So again, remember, you can't have, the R group cannot be a hydrogen anymore. That was just for aldehydes. So here's a couple of examples with, here's the carbonyl group, and then R group, carbonyl group, R group, and the carbonyl group doesn't even have to be in the center, so it can be at the end, like towards an end, and here's like a long one over here, or a long R group over here, and this would still count as a ketone. So I commonly hear students getting confused between aldehyde and ketone, and I guess my tip would be an aldehyde has an H in it, while a ketone doesn't, like in the name. So an aldehyde would be the one that has an H as one of the connections to the C of the carbonyl group. And since a ketone doesn't have an H, it wouldn't have hydrogen as the connection to the carbonyl carbon. So the next one is carboxylic acids. And a carboxylic acid is a compound with a carbonyl group attached to an alkyl group and an alcohol group. So the representation is over here. There's two different ways of representing it. I usually do the second one, but I can explain both. So this one, here's the carbonyl group. It's attached to an alkyl group, which they call the side group over here. It's in red. And this alcohol group, the OH part, is the alcohol group. Another way is, again, here's the carbonyl group, and the R group, the carbonyl carbon is attached to the R group and an alcohol. So again, there's multiple examples for all of this. Here's like a bunch of acids, and honestly, you don't even have to have just one carboxyl group. So here's a couple of compounds with two carboxyl groups, and oh yeah, here's one that has 3 carboxyl groups. So I mean, no matter what number you have, as long as you have at least one, then that compound has a carboxyl group. And this diagram is again something I wanted to include because this compound has a carboxyl group, but also has a benzene ring, which is an aromatic functional group, and then it also has 2 ethers, which we talked about earlier. So again, this is something that you'll need to develop, which I'm sure you will with practice, because it seems like a lot, but as you practice it, they get easier, and I'm sure you guys will just breeze through it in no time. But I just want to like show that you can have a compound with multiple functional groups, and it would still be like those types of compounds exist. So yeah. The next one is an ester, which is a compound with a carbonyl group attached to an alkyl group and an ether, a partial ether group. So I remember esters because it sounds really similar to ether. So before I explain that, let me just explain the representation. So here's the carbonyl group. The carbonyl group is attached to an R group on one side and an OR group on the other. And if you remember from our ether slide, I said ethers are represented as R-OR. So, I mean, you can see how it's like R, and then think of the C as dash, and then OR. So, I mean, I don't know, I feel like the similarity of the sounds of ester and ether make it easy for me to remember what exactly an ester looks like, because I feel like ethers are easier to memorize than esters because I haven't heard of an ester before, like this class, where I did hear of ethers. So here's a couple of examples. There's one over here. So there's the carboxyl group with an O and R group on one side and some other R group over here. And interestingly, this one is, well, never mind. No, it's not an amine, sorry, since it's double bonded. But yeah, there's a ring structure over here, so that would be the R group over here. And again, here's some more examples of an ester. So there's ethyl methanoate over here, and then again the carbonyl group, R group, and R group over here. So we're amides, and again, amides have the primary, secondary, tertiary amide classification, and they also follow that exception that we had with amines, where you look at the number of carbons that are attached directly to the nitrogen. But before I get ahead of myself, an amide is a carbonyl group that's attached to an alkyl group on one side and a nitrogen atom on the other. So you can see over here, there's carbonyl group, alkyl group, and then the nitrogen group. And this is primary because nitrogen is only connected to one carbon. Here's a secondary where it's connected to two carbons, or, well, two R groups, really. And then here's a tertiary one where it's attached to three R groups. So again, amines and amines and amides are the ones that follow the exception for the primary, secondary, tertiary classification. Everything else is the normal look at the carbon that is attached to, and then look at the carbon that the functional group is attached to, and look at what else that carbon is attached to. Okay? So here's some examples of amides. And here's a more complex example of an amide. So yeah, okay. So the next one is acid chloride. And acid chloride is a compound with a carbonyl group attached to an alkyl group and a chlorine atom, which isn't that hard to remember because chloride, like, it's in the name, so I don't think it's hard, at least not for me. So again, here's the representation, the carbonyl group attached to R group and chlorine. And you can look at some examples over here. So there's carbonyl group attached to chlorine, so this is the acid chloride group, and then you can see that there's a carbon attached to a halogen. So do you guys remember what that means? Like what functional group that is? It's a alkyl halide functional group, so there's that. And then here's another one that kind of looks pretty because it's really symmetrical. So yeah, here's a compound with three acid chlorides, or acid chloride functional groups. So the next one, and the last one I believe, is an anhydride. An anhydride is a compound with two carbonyl groups joined by an oxygen atom in the middle and alkyl groups on the remaining side. So this is really the only functional group in the carbonyl classification that has two carbonyl groups. So here's one carbonyl, another carbonyl, that are attached by an O in the middle and an R group on either side. So that's their representation. So you can look over here. So there's the two carbonyl groups that are attached by the O in the middle, and then there are R groups, and another example over here. So again, an anhydride would be another one of those compounds that I said earlier that you could put on a lower priority because we don't really talk about anhydrides much in organic chem, but you would in like future chemistry classes depending on kind of what your chemistry journey is. But all the other ones that we talked about, like carboxylic acids, ketones, alcohols, amines. They're pretty common, and you'll see them a lot in like reactions and all that. So it would be a good idea to like memorize them, and a good habit to kind of keep your brain sharp on those um, functional groups. So now that we've gone through all of these, I I have a little activity for you. So if you're not ready for the activity, that's completely fine. I do not expect you guys to have memorized all of these function groups by looking at this video once. So I would say just keep practicing, and once you're confident, you can come back. But if you want to try it, here it is. So I have a compound drawn out over here, and I want you guys to identify all the functional groups that are present in this molecule. I will stop talking in a minute where you can like pause the video and you can kind of work on it for a bit and then play it, and I'll show you the answers. So yeah, I'll be quiet. Okay, so now that you guys have gotten a chance to work on it, here are the answers. So again, we'll go over them together. So we'll start from this top corner. So we have a C double bonded to an O, so carbonyl group with an H on one side and an R on the other. So that would be an aldehyde. And then we keep going, we see an O. We see an O that has an R group on either side. So that would make it an ether. And then we keep going, and then we see another carbonyl group with an O on one side, or O R on one side, and just a normal R group on the other. So that would be an ester. Then we keep going and we come over here and we see that there's a triple bond over here. So that's an alkyne. And we keep going, we see a carbonyl group that's attached to a alcohol group on one side and a R group on the other. So that's a carboxylic acid. And we go back and then we keep going down and we come over here and here's a double bond. So that's an alkene. And then, you come over here and you have a carbon attached to an alcohol group. So again, obviously it's an alcohol. We come over here and we come across a nitrogen. And nitrogen has one hydrogen and two R groups. So it's an amine or amine. Specifically, it's a second degree amine because it has two R groups. And then again, keep going. You get another carbonyl group that's attached to an R group on one side and a nitrogen and on the other side. And this one's an amide. And again, this one's a first degree amide because it's only attached to one R group, the 1C. Because it has two H's on the other side over here. So we go back and we come down here and we look at this, benzene. And this is aromatic. And then we go down and we look that there's a carbon that's attached to bromine, which is a halogen. So that's an alkyl halide. And then we keep going, we see another carbonyl group, and it's just R groups on either side. So that is a ketone. And then you have another amine. We have two amines actually in this one. So there's an amine over here and an amine over here. And well, it looks like this one has 1, 2, 3 R groups, so that's a third degree amine. And this one has 1, 2, and an invisible H. So it's a second degree amine. So there's 3 amines in here. But anyway, that's all the functional groups that we have over here. Notice that I never mentioned alkane, which I think is the only one of the only major functional groups that aren't covered in this example. That's because alkanes are basically single bonds between C's and H's, right? And they're literally everywhere. So it's kind of preferred that you don't point out the obvious, basically. But if you wanted to point it out as practice, then here's an alkane over here. Alkane, 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 alkane. So basically everything that you didn't circle is now an alkane. But okay, so that was that. And how did you guys do? I hope you guys did great. I mean, I think you did because you've been paying attention to the whole video. And even if you didn't, that's okay. You're still learning, you're practicing. I'm sure you'll get there. And you can come back, once you practice a little more, you can come back and do this, come back to like this part of the video and do it again. And I'm sure you get all of them. And if you did get all of them, then great job, you've mastered this. Now you can move on to the next thing. So that was all I had for today. Thank you for watching. I hope this was helpful. I mean, I really do. I spent a lot of time into this. But if you still have more questions, you can contact your professor, or you can stop by the Math Science Center in the Jack and we can help you. We'll be very glad to help you. So, good luck. Thank you.